Hello, I'm Bruce Dell, CEO of Unlimited Detail, and I've been given 5 minutes, no more, to explain what Unlimited Detail is. We're going to have to keep it a little bit simple for those who are new to an understanding of three-dimensional computer graphics. So, back to the basics. Here we have a picture of a spaceship made of little flat shapes. In computer graphics, we call those little flat shapes polygons, and at present, nearly all computer graphics on our games are made using the polygon system. That's where we make everything out of little flat shapes. Now, they're not always grey and boring like that. Normally, they put pictures on them, like this. Whenever new Nintendos come out, or new Sonys, or new Xboxes, or new graphics cards, they're trying to make them more powerful than the previous ones. When we talk about more power in 3D graphics, what we normally mean is more polygons. Because if you have more polygons, then your things won't look quite so angular and sharp. They'll start to look a bit more round. Obviously, a lettuce that's only got 5 sides isn't going to look as good as a lettuce that's got 10 sides. Ideally, we would prefer a lettuce not to have any flat sides at all. And certainly that's where we're going to be in the future. Things in the real world aren't made of flat pieces of cardboard. And so the idea is that technology will continue to progress, and the polygons will get smaller and smaller, and the objects will get rounder and rounder, and then one day we'll have so much computing power we will abandon polygons altogether and move to what's called the point cloud data system. Point cloud data is where you make your objects out of little points instead of polygons, tiny little dots. The dots are all coloured like little floating 3D atoms. Then everything would be lovely and round, and the geometry would all be real. And brick walls would be real geometry as opposed to flat pictures. But the problem with doing that is every single point takes up a little bit of time for the computer to process. The computer has to do mathematics and trigonometry and multiplication and division. So if you tried to build your whole world out of these little 3D atoms, and we had trillions of them, then it would probably take the same amount of time to build one frame as it took the Egyptians to build the pyramids. There's been some fantastic demonstrations by ATI and SGI and even NVIDIA where they've run millions, sometimes as much as 1 billion points of point cloud data on very, very big supercomputers. Oh look, half my time is gone. I better start talking about Unlimited Detail. Okay, have a look here. What have we got? We've got great big pyramids of some very unusual looking little animals. Each of those animals is made of millions of points. And we've got thousands of these animals. We've got about 8 billion points running here because we've also doubled them all, put them underneath to make reflections. And all of this runs in software. We're running unlimited point cloud data in software alone. This is the largest breakthrough in three-dimensional technology since computer graphics began. I think you can best understand its significance like this. There's 2 large polygon companies. We'll call them polygon companies to make it nice and simple. One's called ATI and the other one's called NVIDIA, and they don't seem to like each other very much. And they spend a lot of time and billions of dollars fighting each other, always trying to build bigger, stronger graphics cards with more polygons. At present, the polygon count goes up about 22% a year. And a lot of people do a lot of work building very, very powerful microchips to have it go up that 22% a year. Unlimited Detail didn't increase the polygon count by 22% or 100% or 1000%. We have unlimited graphics power. You can't have more than unlimited. It's the end of the race for geometry. It's a little bit like when colours started at 2 colours for a computer screen, and then they moved to 4 colours, and then 16 colours, and then 256 colours, and then 16-bit colour, and then 32-bit colour. It stopped there. It didn't go any further because our eyes can't really see any more than that, and so that was the end of the colour race. Unlimited Detail is the end of the geometry race. And we can now leap over the next 20 generations of computer graphics cards and go straight to unlimited graphics power. I have only 30 seconds left. Can I ask for a little bit more time? Unlimited Detail first appeared about 6 years ago. A game had just come out called Rome Total War. We're looking at it now. They had made a whole city out of polygons. And there was much awe and amazement. So we at Unlimited Detail also made a city, but we made it out of unlimited point cloud data, and we have more facets of geometry in one tile on the roof than they had in their entire city. We sent it off to a certain company, and the technical people at the certain company didn't like the idea of abandoning polygons, so they refused to let us get through to the board of directors. That sort of thing's not uncommon. There's a lot of people who like polygons a lot. But polygons have a lot of problems. I mean, the first one is things look angular. Second one is they're rather limited. You don't have unlimited polygons. The best way they can make things look like they have a lot of polygons is to use the model swap system. Perhaps you're familiar with it. If we look at this scene, as we get closer to the tree, we notice that the tree sort of jumps, it sort of changes. What it's doing is a model swap. They've made many different trees at different sizes, and they swap them. This saves polygons. With unlimited detail, we don't have to do any of that. If you're in the industry, you would be looking at this and saying, something doesn't add up here. How can you have unlimited graphics power? Everybody knows a computer takes time to process whatever amount of tasks it's given. If you give it unlimited tasks, then it's going to take a very, very long time to process that. If you give it billions of points, you're going to have a problem. And so unlimited detail just shouldn't be possible. And that logic is sound and good and wise, and I would agree with it 100%. But unlimited detail is not based on the normal rules of making three-dimensional geometry, whereby we would have to do more processing to have more stuff on the screen. Unlimited detail is basically a three-dimensional search algorithm. A search algorithm is, well, Google, Yahoo are good examples, or when you go onto a Word document and you type search at the top and put in a word like money, and then suddenly it shows you all the places where it appeared. If you think about Google, Google also looks a little bit like it has unlimited power. I mean, it's searching through all the knowledge on the earth, and it doesn't seem to take very long. Unlimited detail is using the same principles, it's just applying it to three-dimensional graphics. We have a way, rather complicated way, of searching through unlimited amounts of point cloud data and grabbing only the points that we need. How many do we need? Well, we really only need one for every pixel on the screen. If your resolution is 1024 by 768, that's all the points you need. It's a little bit complicated to be able to grab exactly the ones you need, taking into consideration things like perspective, how small the object is anything covering the object, etc. But we've found ways around this. So our algorithm is vastly different to voxels, which is conventional ways of doing point cloud data. That's limited. Avoid that. It's different to polygons. They've served us well, but they have a use-by date. It's different to making scenes through ray tracing. That's a very, very, very slow process. It's a fourth system, one which is very fast and gives us unlimited geometry. We're in the process of negotiating funds to make the SDK at the moment, so God willing, you'll probably see unlimited detail in about 16 months' time. And that would be the end of the explanation.